그렇군요. 네, 시작하겠습니다. 네, 하겠습니다. Hello, welcome to EE405 class. I'm Jiwon Kim, TA for the Introduction to Robotic Manipulator. So here are the contents for today. First, we'll briefly cover the vision system, which include camera model and camera calibration and RF marker detection. And we'll move on to grasping pipeline and talk about the pick and place, which is the final result for today. So this is the final result video. So the three boxes are randomly posed, and then the robot picks it up by detecting the RF marker shown there, and then place to target location. So in this video, the three boxes are stacked up on top of each other. So first, let's talk about the camera model. So there are basically two kinds of parameters. First, the intrinsic and distortion parameter, which project the camera coordinates to the 2D pixel coordinates. So, and then there are extrinsic parameters, which basically the pose of the camera coordinates with respect to the world coordinate. So today, so once we know those parameters, we can map the 3D world points to the 2D pixel coordinates and vice versa. So today we are going to obtain the intrinsic and distortion parameters through camera calibration, and then obtain the extrinsic parameters through the RF macro. So the first task is the camera calibration. So for this task, you guys don't need to any implementation. You can just use the simply run the given project code. So the execution process goes like this. So first you will run the calibrate underbar cam.py file. But before you're running it, you have to check the checkboard setting on the code match to your own checkboard, and then you position the checkboards to the camera, and then press enter to save the image. So you will need to capture more than 20 images, covering all the field of view. And after the calibration is done, the intrinsic and then distortion parameters will be saved. So next, let's talk about the RF marker, which we use to obtain the extrinsic parameters. So an RF marker is a type of fiducial marker that has a predefined ID, so that in the image it can be easily recognized. So once the marker is detected, the algorithm finds the four corners of the marker, and then with the known length, the algorithm can recognize the marker and then estimate the extrinsic parameters, which is basically the pose of the marker. So in this task, our goal is to detect the RF markers given image and then estimate their pose. For implementation, it is recommended to use the OpenCV 405 or later, which have the built-in RF marker detection functions. So make sure you use the camera intrinsic and distortion parameters from previous task. The third task is implementing a grasping pipeline. In this task, the goal is to make the grasp based on the pose detection from the RF marker. You can check the pseudocode here. Simply speaking, you first detect the marker, and then based on that, you reach the target through solving the inverse kinematics, and then grasp the object, and then return to the home position. So for this task, you can design your own algorithm or function. This is the one possible solution. The last one is the pick and place. This is the final project for today. And the goal is to move the objects to the desired location using your own RF marker based grasp. So 3 blocks will be placed at a random pose in your robot, and your robot should pick them up, like in the video. And then place to the target position. So you can use the box, the big box shown here, to adjust the height of the 3 boxes. And you can define your own desired position and make sure just process all the pick and place procedure. It's just keeping. It's the same video. Here's a summary for today's tasks. This slide lists what you need to implement for each task and which script you have to run for debugging or testing. So please make sure read carefully and keep it handy for your implementation. And then this is the evaluation policy. And if you successfully perform the task shown in the video, you can get the full 7 points. And if it's not, you still get the partial points as shown on the slide. Then if you finish all the tasks today, you can just show me your results today during the lab session. But if everything works well, you can get the full score. But if not, you will have 2 more weeks to complete. And for this case, you'll need to submit a video that clearly shows your robot performing the entire task and with your source code. Please also check the deadlines on the slide. And then this slide explains the instructions for video submission. So if you plan to submit a video, please check this and record your video accordingly. And that's it for today. Thank you for listening. 혹시 질문 있으신가요? 없으시면 하시면 되겠습니다.